Hello everybody, let's do question 2 of this momentum, the new momentum. So let me read it. A ball with mass 0.160 kilograms has a head-on collision with a second ball initially at rest. After the collision, the second ball moves off with half the speed of the first ball. So the first part, 2a, is what is the second ball's mass, and 2b, what fraction of the original kinetic energy gets transferred to the second ball. So the first thing we should do is probably draw a picture. So let's draw the two scenarios. Let's say before collision. I'll just say before. So before, what happens here? Let's have a ball with mass A. I'm just going to call them a ball A. And it's traveling with velocity VA. And eventually it collides with a ball over here with mass B, and this ball is at rest. And then after the collision, so they collide, and that's when momentum and energy is transferred. So then what happens is, afterwards our ball here with mass A will now have velocity A prime, and then the ball over here, mass B, will now have velocity VB prime. And let's just put an arrow to show it's going that way. Now the thing is, they tell us here, and this is very crucial, the second ball moves off with half the speed of the first ball. So VB prime is equal to half VA. So that's why it's very important to read carefully. There's often some clues in the text. So let's see what we can do. So simple basic conservation of momentum tells us that momentum before is equal to the momentum after. So the momentum before is the momentum of each ball. So mass A times VA plus mass B times VB, and then this is equal to mass A times VA prime plus mass B times VB prime. And now we can just simplify a bit, so we know that this is 0 because it is at rest. So we just have mass A times velocity A is equal to, and then mass A velocity A prime, and now we can replace VB with a half VA. So this becomes half, well, the VB prime, sorry, and then it's half MA VA. So we just replace this with half VA as was given to us. And then now the thing is, we've got two unknowns. We don't know what VA is, and we don't know what VA prime is. So two unknowns in one equation. So that's not going to help. We need a second equation. But before we get a second equation, let's just simplify this a bit, or let's make VA prime the subject of the formula. So we get MA VA prime is equal to a half MA VA minus, so I'm minusing MA VA So now we can simplify a little bit. So we know that this term here is 0 because the velocity of ball B initially is just is at rest, so it's 0. And then we mustn't forget that this VB prime is equal to a half VA. So let's just put all that in the next line here. So now we have mass A VA is equal to mass A VA prime plus a half mass B VA. Now the thing is, we've got two unknowns here. We've got VA prime is unknown and VA is unknown. So two unknowns but only one equation, so we can't solve the system. We're going to need another equation. But before we create another equation, let's just make VA prime the subject of the formula here. So what I'll do is, let's do MA VA prime is equal to, and then we have MA VA, and then minus a half MB VA. So this is some algebraic manipulation there. I'm just subtracting a half MB VA from both sides, and then it's divided through by MA. So it's, you can always put a comment or something just to say divide by MA, or you could even write a full sentence if you want to explain the process. So now we have VA prime is equal to, so if you divide through by MA, this one will cancel, so you'll just have VA minus, and then you'll have MB over 2MA VA. And we can simplify even a little bit further. We can factorize the VA out. So we end up with 1 minus MB over 2MA times VA. And in fact, you know what, let's do one more step with that fraction there. So we'll have VA prime is equal to, so if we say 1 minus some fraction, we need the common denominator, so 2MA will be the common denominator. So 2MA minus MB all over 2MA times VA. Now I think we should label this equation. Let's call it equation star. So we're going to need to use this equation in another way. So now let's look at conservation of energy, or let's look at the kinetic energy. Let's say energy conservation. And this implies that the kinetic energy is conserved here. So the change in kinetic energy is 0. So the kinetic energy before the collision is equal to the kinetic energy after the collision. So the kinetic energy before is a half MA VA squared plus a half MB VB squared, and then it will be equal to a half MA VA prime squared plus a half MB VB prime squared. And then okay, we know again that this guy is 0, and we're going to substitute the VB here. We're going to substitute a half VA in there. So here we have a half MA VA squared is equal to a half. In fact, we could have cancelled the halves out, but okay, we'll do it to the next step. VA prime squared, and then here, just be careful here, so we go a half MB, and then this guy is a half VA all squared. So it's important there not to make a mistake. And I think I will cancel these halves out. And now we know from equation star, we have an expression for VA prime. So what we can do is we can just square that expression for star, and then we can plug it into this equation we're currently busy with. So let's take star squared, and then this will give us VA prime squared is equal to 2MA minus MB over 2MA squared VA squared. Now this can be plugged into our equation that we're currently working with. So the equation we're working with now becomes MA VA squared is equal to MA, and now we plug in the star over here, so this will just be 2MA minus MB over 2MA squared VA squared plus MB, and then it's a quarter VA squared, because a half squared is a quarter. So we notice that there's VA in all these terms, so we can factor it out, but let's get everything onto one side of the equal sign. So let's do this. So the first thing we can do is, okay, let's just get them all onto one side. So we'll have MA VA squared minus MA. So I mean, it's just a repetition here. We're just moving them to one side. I think what I should do is let me do this. Let me make this thing squared, and then the bottom is 4MA squared, and then VA squared, and then it's minus a quarter MB VA squared, and this is equal to 0. So we moved everything to one side. So we can factor out the VA squared, and all this will be, and then this MA will cancel with the square over there. So we have MA minus two MA minus MB all squared over 4MA minus MB over 4, and this is 0. So now it's just a little bit more algebra. We just have to expand the inside of the brackets, because this will mean that VA squared is equal to 0, or this is equal to 0. So let's consider what happens when that algebraic expression is 0. So what we can do is, we've got a denominator here of 4MA. So let's get all of these terms under 4MA. So that means for this to be under 4MA, we must multiply top and bottom by 4MA. So we end up with 4MA squared minus, now let's expand this bracket here. So 2MA squared becomes 4MA squared. Negative MB squared is going to be, so it's minus, so it will be minus MB squared. And then the cross term over here is going to be positive 4MA MB, and then minus, so this MB here, we have to multiply it by MA MB, and this is all over 4MA, and this is 0. So for this to be 0, the numerator has to be 0, but we can simplify. So 4MA squared minus 4MA squared, they disappear. 4MA, the MA times MB minus MA times MB is 3MA MB, so we end up with 3MA mb minus mb squared is equal to 0. And a little bit more factorizing, we just take the mb out here, so we end up with 3ma minus mb times mb is equal to 0. So either mb is equal to 0 or 3ma minus mb is equal to 0. And this means mb is equal to 3ma. And we know what ma is. So now we can calculate what mb is. So this is 3 times 0.160 kilograms. And this is 0.480 kilograms. So that's what the mass, second mass is. That's its mass. Question B asks, what fraction of the original kinetic energy gets transferred to the second ball? So now we're just going to take a ratio here. So the kinetic energy of the second ball, so let's do this, kinetic energy of B would be equal to a half mb vb prime squared, and then the kinetic energy before the collision, so this is just before, because we want to know how much energy was transferred from originally before the collision. The kinetic energy here is only due to the first ball because the second ball was at rest, so VA squared. So we just want the ratio here, so we can just do kinetic energy of ball B over the kinetic energy before the collision. And what is this equal to? This will just be, so the halves will cancel, so it will be mb vb prime squared over ma va squared. Now we know that mb is 3 times a, so this is equal to 3 times ma vb prime squared over ma va squared. So the ma's cancel, and then we also remember that vb prime is a half va, so we have 3 times a half va squared over va squared. So the va squared cancel. A half squared is a quarter, so this is just 3 over 4. And that's actually the correct answer. So we can say, therefore, 75% of the initial kinetic energy gets transferred to the second ball. And that's it. So let's move on to question 3.